Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class, we are going to discuss a numerical on the topic moment of inertia. Let's go to the numerical. For the given figure, compute the moment of inertia about axis KK. Okay, here main thing is we are going to use the parallel axis theorem. Okay. First of all, what is parallel axis theorem? That we discussed in a separate video. For the reference, that video link is given in the description box of this video. For better understanding of this numerical, watch that reference video. That is, go to the description box, click the video link, parallel axis theorem. That will be very useful for understanding this numerical. Okay. Here, this diagram or the figure or the section, whatever given here, it consists of two rectangles. I am going to split these two rectangles here. Okay, we can split whatever. Here I am going to split the rectangle here. So this will be the first rectangle and this one will be the second rectangle. First rectangle with the dimension 40 mm and 120 mm. 40 mm width, 120 mm depth. Second rectangle 240 mm width and 40 mm depth. This entire section is at a distance 100 mm from the KK axis. For about, we are going to calculate the moment of inertia. Okay. Here, the center of gravity of the entire section is not needed, but the center of gravity or at least the x values of these two rectangles, individual rectangles we need. And then the area also we needed. So that things we are going to consider here. So first of all, for rectangle 1, okay, first for the rectangle 1, the segment 1. For that, A1. Here you can see when I split the rectangle here, this will be the first rectangle, width 40 and then the depth that is 120. So 40 multiplied with 120, then we will get 4800 mm square. And then x1. Here generally we will take this leftmost line as the reference line. Just to show you here. Okay. Generally, we will consider this line. That is the leftmost line. Okay. This one. This is the leftmost line as the reference line. From the reference line, here you can see this width is 40. So 40 by 2. Okay. 40 by 2. This x1, that is from reference line. So we can write 20 mm. This is from reference line. Okay, I just write this reference line. But the H1, that is the distance of KK and the axis passes through the center of gravity. Okay, here we are going to consider. That means here you can see the center of gravity 20 mm means it will be here. So this parallel axis, okay, to the KK that passes through CG1, that will be this one. Do you understand? So the H1 will be this distance. That means this is H1. That is from KK, axis KK to this axis. That distance is actually H1. The H1 we can write as, that means up to this 100 and this distance that we calculated 20 mm. Okay, so we can write this 100 plus 20. That is 120 mm. Okay. Then we are going to do the same calculation for rectangle 2. For the rectangle 2, first of all, area A2. This one, 240 width and 40 depth. So this will be 240 multiplied with 40. So we will get the value of A2, that is 9600 mm square. Then X2, same, this is from a reference line. Okay, from a reference line, not from KK. This is from KK. This is from axis KK. So X2, here you can see from this 240 by 2. So we can say this is 120 mm. So here, this 120 means the axis will be this one. Okay, that means 240 by 2. So this will be the another axis, passes through its center of gravity. And then this is the distance. Okay, from the axis KK. This distance we are going to take as H2. This distance from the axis KK to the vertical axis passes through CG2. This one, center of gravity 2. Okay, probably here CG1. Okay, 120 by 2 and 40 by 2. This is H1 and this distance is H2. So H2 we can write up to this 100 plus 240 by 2, that is 120. So 100 plus 120, that is 220 mm. This is measured from KK. Okay. Now we are going to calculate moment of inertia of the diagram or of the section about axis KK. Okay. First here, moment of inertia of the axis or moment of inertia of the rectangle 1 passes through an axis, passes through its center of gravity and parallel to KK. That means this axis. Okay. That one I'm going to write as, okay, I'm going to write as moment of inertia of the rectangle 1 about an axis passes through its center of gravity, that is through CG1, and that is parallel to axis KK. Okay, parallel to the axis KK. That is IG1. Okay, that I'm going to take as IG1. That formula will be dB cube by 12 because this parallel to the vertical axis. So dB cube by 12. For this, the D, that is 120. This is D, 40 is B. So 120 multiplied with 40 cube, that divided by 12. By simplification, we will get IG1, that is 640 into 10 power 3 mm power 4. Then moment of inertia of the rectangle 1 about axis KK. Okay. That is, I'm going to take as IKK about the first rectangle. We can use the parallel axis theorem. This one, Okay, moment of inertia of this axis that we calculated as Ig1. About this axis is Ig1. About this axis for the first rectangle, Ig1 plus A1 H1 square. Ig1 plus A1 H1 square. Here Ig1 we calculated 640 multiplied with the 10 power 3 plus A1 we calculated 4800. Okay. Multiplied with H1, that is 120 mm. So 120 square. So when you simplify, the value of IKK1, that will be 69.76 multiplied with 10 power 6 mm power 4. Okay, this is IKK1. Same way we have to calculate IKK2. First, moment of inertia of the rectangle 2 about an axis. Okay, moment of inertia of the rectangle 2 about an axis through its center of gravity, that is CG2 and parallel to KK, because then only we can use parallel axis theorem. That is through this axis. Moment of inertia of the second rectangle through this axis. That axis here it is mentioned which passes through CG2 and parallel to KK. Okay, simply moment of inertia of the second rectangle with respect to this axis. That is IG2. Okay, so IG of the second rectangle, that equal to same formula dBq by 12, but here different d, different b. For that second rectangle, depth is 40 and then the breadth, that is 240. Okay, so 40 multiplied with 240 cube divided by 12. So by the simplification, the value of Ig2, we will get 46.08 multiplied with 10 power 6 mm power 4. Okay, that is Ig2. Now we have to calculate IKK2 as we calculated in the rectangle 1. Moment of inertia of rectangle 2 about axis KK. Okay, that is IKK2, that equal to this Ig2 value A2 and this distance, parallel perpendicular distance between the two parallel axes, H2 square. So Ig2 plus A2 and H2 square. Here we calculated the value of Ig2. Substitute all the values. That means Ig2 was 46.08 multiplied with the 10 power 6. And then we calculated A2, that is 9600, and then H2, that is 220 mm square. So 220 square. Then if you simplify all the values, IKK2, we will get 510.72 multiplied with the 10 power 6 mm power 4. Okay. Then moment of inertia of the whole section about axis KK. Okay, about axis KK. So IKK kk, that equal ikk1 plus ikk2. Okay. So now add both the values. We can write ikk, that equal to, we calculated ikk1 69.76 multiplied with 10 power 6 plus ikk2, that is 510.72 multiplied with 10 power 6. When you add, we got the value ikk, that is 580.48 multiplied with 10 power 6 power 4. Okay. So this is the final required value. Okay. So I hope you all understand this video. Don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver, for more number of videos. Okay. Thank you guys. Thanks for watching.